Hello, everyone. Thank you for tuning in for this episode of the Amazing Podcast. We hope you're enjoying all of the conversations we're having around cloud native computing. My name is Twain Taylor. I'm the editor at Amazing. And if you like what you hear on this podcast, definitely head over to our website, amazic.com. That's AMAZIC.com. You'll find a lot more content just like this. I have with me today Steve Van Leer, who is the VP of Engineering at Anjuna. So Anjuna is a startup, and it's in quite a niche space. And I'm really interested in hearing about what they're up to. So Steve, it's great to have you with us. Thanks for joining. How are
Oh,
you
my
doing?
pleasure. It's great to be here.
All right. So Steve, as we get started, tell us a bit about yourself. What's your background? What have you been up to before Anjuna?
Super. Yes. So my background, I started out my career actually as a hardware engineer doing ML work for DoD and other governments. At the time, in the 80s, it was hard to do machine learning in software, it just wasn't fast enough. So we built these very large systems to do it in hardware. And I had a tremendous amount of fun and spent the early part of my career doing that. But I wanted to switch to software and ended up doing it probably the most Silicon Valley way possible. I kept knocking on doors, and people would say, well, we don't need somebody who can design a $600 toilet seat. We don't need a hardware engineer. So I just started up my own business with a friend, and we started up a supply chain business in the mid 90s. And from that company ended up being purchased by Agile Software, which got purchased by Oracle. And I found myself running the PLM team at Oracle for a number of years. Really enjoyed that, but I like the time in small companies. So what I've done since then is I've tended to go to small companies. They then become a large company, and I decide it's time I want to be back in a small company again and repeat the process. So I've run fraud prevention systems for a company called 41st Parameter that became part of Experian. I ran the AI team at Automation Anywhere for a while and a couple other startups in there. And when I got approached to join Anjuna, the recruiter called me up and said, Steve, I know this isn't the template of job you're looking for. They're a small pre-revenue company. He goes, but I think your background will fit really well. And he talked to me about Anjuna and talked to me about assembly code and this boundary of some new capabilities to encrypt memory in a CPU. And I got pretty intrigued and ultimately went from being a skeptic to how do I get in the door and work
Mhm.
at Anjuna. So been there for the past 4 years, building out the team and building out the technology.
Wow, really cool story. Sounds like you got a lot of experience with security as well as hardware. Really cool combination there. Um, and Anjuna, interesting name. I was chatting with one of your colleagues, and they mentioned that the name comes from India, which is my home country. Uh, yeah, could you tell us a bit more of that story?
It does indeed, and it actually ties into the name of the product, Sea Glass, interestingly enough. But Anjuna is a beach in India, of course, up in Goa. And our CTO founder was on the beach when they had to sign their first NDA. And the other founder called him up and is like, hey, we need to get this NDA signed. We have to pick a name for the company, and we want something that starts with an A. And he said, well, this is a pretty cool beach. Why don't we just name it Anjuna? And the other founder said, fine, let's do it. And so they named the company Anjuna. And so that's where that came from. And when we were looking at what to call the product, we looked at a lot of different names, but really liked the name Sea Glass because it had a connotation back to the beach. It had a connotation of something that starts out as clear glass and it becomes opaque, secure after it's been through the process of becoming sea glass. The colors happen to match the colors that we were using in the company. We a lot of times will describe our technology as protection around an application, and we draw these little glowing cubes around the VMs. And that all kind of looks sea glass as well. So sea glass got to tie in with the founding of the company's name as well.
Wow, really cool. Lots of layers of meaning there. I love that. And
Yes,
also because brings back good memories because I have vacation right there.
that's
But
nice. I've had teams in India for years and years and years. I miss going there.
yeah, 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 you should. Lovely place. Um, and I want to just dive into the key phrase of what we're talking about today, which is confidential computing. And I've been around in the space for more than a decade and read quite a bit, but I've not really come across this term much, confidential computing. I've come across similar terms, talking about how do you make sure that your infrastructure, your software is secure related to compliance and all of that. But confidential computing itself as a term, I haven't really heard it before, Anjuna. So could you tell us a bit about confidential computing, what it means, where it comes from? Because I'm sure a lot of listeners and viewers here are as well hearing this for the first time, confidential computing, and wondering what this is.
Absolutely. And while you haven't heard the term confidential computing before, it is an industry term. A series of chip manufacturers have come together and standardized on that in terms of what they're creating in terms of the security model, but you have used it. So on your credit card, the chip has a protected area that it does computation so that somebody can't get access to your credit card number and your PII.
Mhm.
So that was probably the first use you had of it. Probably the next big use you have it on is your mobile devices. So as the mobile companies were trying to figure out what to do with biometrics, phones get lost, phones have an ecosystem of a lot of connected things. How do they protect your biometrics from getting lost or being stolen? And so they're using what's called an enclave, a trusted execution environment that's built into the CPU, and the biometric data is actually stored and protected inside of that confidential computing environment. Around 2015, Intel rolled out a version for the x86 chips called SGX, Secure or Software Guard Extensions. And Intel then seeded the CPUs into a lot of the research community to try to break it and find ways to crack into it. But I think rather than go through the history, it's a little bit better to explain what is confidential computing in practice. And our data exists in three states. And we can think of storing our data. So you put it on disk, and we have ways to encrypt data when we store it. We can move data, and you can put it on the network and you can move it from one computer into the next computer, and we'll secure it and encrypt it with TLS. But the third state is when you're using data. Um, and computers have a fundamental assumption that somebody owns the computer, and the person who owns the computer has access to everything that's on the computer. Matter of fact, you can go back to the old mainframes, and they literally had blinking lights on the front panel that would show you what the memory state of the machine was. But when we move to the cloud, the advent of cloud computing really means that the person who owns the computer and the person who's running jobs on the computer aren't the same organization anymore. And
Yeah.
so the fact that the person who owns the computer still has access to all of the memory and everything that's on that machine, there's a big hole there. There's a threat that somebody can steal the data. And the threat's always been there, right? We've had programs that get onto your machine and then steal data out of other programs' memory for a long time. If you have ever looked at a core dump, there's all sorts of crazy things in a core dump that happens to be what the application was processing. So confidential computing was designed to solve that problem, to be able to take a workload and isolate that workload from the rest of the system. So even if you've got command line access, you've got system access, you're the hypervisor. How do I protect my application from those threats? How do I protect my application from somebody that's got access to root, getting access to the data that I happen to be processing? So this is why the clouds have been investing in confidential computing. A lot of the banks, for example, they all have a migrate to the cloud project. And the reason they all have a migrate to the cloud project is they're trying to figure out control equivalency. They're trying to figure out how to protect their workloads. Because quite frankly, I don't care if Amazon gets hacked. I don't care if Azure gets hacked. What I care about is if my data gets hacked. I care about if my applications get hacked. And so the hardware now exists to provide that protection, to provide that diode that prevents somebody with access from the infrastructure from getting access to your application.
Oh, okay, really interesting. Um, so yeah, you mentioned some of the most like common use cases, but for someone who's listening to this thinking, how do I use it in my organization? I'm just a regular, organization that just uses the cloud, just to run some applications, or maybe they don't associate so much with like a bank or something that's so regulated. For those kind of listeners, how would you say confidential computing matters?
Great question. So I personally believe in the future we won't call it confidential computing. We'll just call it computing because once you can protect the memory of your programs that are running, why wouldn't you want to protect them? TLS, for example, we used to have to buy cards to put in the back of your computer so you could turn on TLS. And, it was a big cost to pay if you wanted to do that. Now everybody turns on SSL. I think the same thing will happen with your computation, but the use cases that we're seeing today is obviously cloud migration, right? That's driving a lot of what the financial institutions are looking at. Key distribution is another big use case that a lot of folks use us for. So you put your keys in an HSM, but when your key comes out of the HSM and you need to move it through the network to go get it to an application or you have to distribute it across your org, how do you protect that key material while it's in use and while it's being transmitted around? So that's a use case that a lot of people will take something like HashiCorp Vault and then put into an enclave using Anjuna and then very simply protect that. We also see a lot of AI use cases. Some time ago, the 2000s, the big data craze, everybody was like, let's build an application that gathers data because the value is the analysis that you want to do on the data. And everybody's kind of reached the state where we understand that if you're giving data to a company, it's because they want to use the data. You are the product at that point in time.
Hmm.
But we still want to do AI and we still want to have data. So we have a lot of AI use cases, particularly in the inference space where you've got an AI company who doesn't want to share their IP, they want to protect it. And you've got a person who owns the data that doesn't want to share their data. So, how do you allow those two to commingle? And yet, the person who owns the data can't get to the AI models, and the person who owns the models can't get to the data, but still get the job. So, we've done a number of jobs in that space with AI inference. And then the other one that was kind of a surprise for me was we've done a lot of work in the cryptography space, and in particular in the secure multi-party compute. So there's tons of research paper and there's tons of work that's gone into how do you secure blockchain, how do you secure these components that usually involves how do you stand up multiple instances that are each computing a part of the problem. So an attacker would have to get into all of them if they wanted to compromise the blockchain. Well, the attackers have proven adept at doing this. I think last year there was about 4 billion in losses in the cryptocurrency space. And so using Injuna and using confidential computing to protect some of that cryptographic work that goes on was really kind of a surprise for me that that was a space that was really in need of some of what we offered.
Oh, wow, really cool use cases there. Um, and I want to dig into ask a little bit more about some of the challenges that organizations face. Let's say, they buy into this concept that, we need to protect our data using confidential computing, take responsibility for it. Um, how easy or difficult is it to get this done? What are some of the challenges and roadblocks along the way? And that'll probably give us a good segue into talking about how Anjuna fits into the
Right.
picture.
Well, matter of fact, that will exactly describe how Anjuna fits into the picture because we exist to make it easier. But I can describe that challenge. And I kind of feel when Intel first rolled out SGX, it's amazing technology, but it sits in between an application and the kernel. And there's a whole bunch of restrictions on what the application can do. And I think the initial model was people are going to think this is so cool and so amazing. They're all going to hire a bunch of assembly language programmers, and they're going to put the secret bits inside of these secure enclaves. And there are use cases and there are companies who have done exactly that. But it's really low level finesse work that you need to do. Lots of things you probably haven't thought about. You know, you've got your program counter that's running along, and then all of a sudden you run an exception and you're going to step out to the kernel. Well, you can't just move the instruction pointer over to the kernel and shift into the kernel space because all of your registers were exposed at that point. And all of your registers might have secret information in them, and then you might leak information out. So there's very strict protocols for how to get into and out of the environment. And that was a lot of complexity. A lot of that complexity has gone away with the confidential VMs, which is kind of the second generation of confidential computing that's hit the market. But you still have to worry an awful lot about attestation, which is a process of proving the code's the right code running in the right environment. And most engineers and most product managers, more importantly, when you sit down and you say, do you want it to be secure? Do you want it to work? The answer comes back, well, let's get it to work and then we'll figure out how to make it secure. And oftentimes then the conversation is it secure enough? And so we take the tack that if you can make this declarative, if you can just make this part of the deployment process and really take applications as is without modification, so they don't have to know about attestation. They don't have to know about how to set these environments up. They don't know how to deal with the boundary conditions. If we can make all that really simple, then more applications will get used and put in this place. Most organizations don't write all of the code they use. Most of the applications on my personal machine are applications I've purchased. Most of the applications at a bank are applications that they've purchased. So being able to use an existing application and configure it for confidential computing, as opposed to modifying it for confidential computing, we think is the right space.
All right, really interesting. With that context, could you introduce us to Anjuna and what approach it takes to confidential computing?
Absolutely. So maybe what I should do is I'll do a quick demo. This is a technical audience, so I'll do a kind of a command line demo. But before I do that, let me set this up with a slide that I use a lot of times to talk about what is the flow that Anjuna adds to the process. So really there's two steps to the process with Anjuna. The first step is we're going to take an existing application. So a customer has a container, and we're going to take that container and we're going to take our policy and we're going to put them together into an image to match the environment that they're being targeted for. So if somebody wants to run in confidential computing in Azure using an AMD chip, that's a different environment than running it in AWS Nitro enclaves or running it on-prem with Intel TDX or running it somewhere else. So our command line will do what's called build enclave, and we will take something out of a image registry or a container registry, and we'll build an image for the customer at that point. And we'll also generate the measurements of the application. So what is the expected result and the expected identity of the code that's running? The second piece of code will launch an enclave. So we will then initialize, we'll set up the environment, we'll set up any shims that we need to get data into and out of that environment. We will then reach out to a tool that we have called the Anjuna Policy Manager. That will do the attestation process that proves the image has not been tampered between when it was put together and when it's being launched now. Once we prove the identity of that piece of code, we may load some secrets into the environment, and then we'll launch the application at that point. So there's a lot of steps that happen behind the scenes, but from the end user point of view, there's only two. We're going to build an enclave and we're going to run the enclave. So why don't I go ahead and show this? So this is, oh, I'm going to have to chat for a second. What I'm going to do is I'm going to take an existing application. In this case, I'm going to take HashiCorp Vault, which is a really sophisticated piece of code. Teams that think in terms of let's make it work or let's make it secure That's not Vault. Vault has made it very, very secure. It's a very well-written piece of code. But all applications, when they're processing the code they want to process, that code has to be in memory. And so you decrypt the data, and that data is exposed in memory while the application is processing that. So even a super sophisticated application like HashiCorp Vault is vulnerable to this threat. And Hashi does a fabulous job of telling customers how to set up their machines and how to protect from this threat. But confidential computing is a simpler way to provide some of those same protections. So what I'm going to do is I'm going to show how to hack HashiCorp Vault, and then I'm going to show how to um, protect it using Anjuna. And the environment I'm going to use is I'm going to use Amazon's Nitro Enclaves. And Amazon Nitro Enclaves is a really fantastic environment where you just start with an EC2 instance. And my demo is not running yet. There we go. So this is just a EC2 instance that I have up and running up in Amazon. So it's an M5 4 extra large. And what Amazon Nitro Enclaves allow you to do is split off a child VM, and that child VM has no access to a network and no access to a file system. And so a lot of the attack threats that somebody would use to go get to an environment have been taken away. And there's a proprietary VSOC interface. So there's a local channel that enables you to provide a connection from that parent into the enclave. So it sounds great, but you have to modify the application so that it works over a VSOC instead of something like HTTP. So let me show the challenge here. So I'm going to start HashiCorp Vault, and got HashiCorp Vault up and running. I'm going to put some secrets into it. I'm going to take some secrets out of it. But the threat that I mentioned is the threat that applies to any application. This is how SolarWinds hack was done. So an application was looking at the compiler's memory while the compiler was running and then swapping files out when it saw the compiler doing things. So in this particular case, I've got a core dump of what was running when HashiCorp Vault was in memory. And I'm going to use a tool that was put together to go through that memory. And it's going to pull out the master key on this instance, and it's going to pull out the secrets that I put into it. And so that very simply describes what an attacker would try to do. An attacker will try to get to the memory of application. So the first thing I'm going to do is I'm going to do the step I described, which is I'm going to build an enclave. So I am going to use the Anjuna tool, and I'm going to build an enclave. I'm going to pull Vault right out of Docker Hub. I'm going to use a configuration file that has all of the Anjuna policy in it. And I'm going to output the image file that the enclave image that Amazon is going to need. So you can see at this point in time, I've got the measurements that came out, and these are the hashes effectively of what was the code we put in. And at a later stage, we'll be able to ask the hardware to reproduce these hashes and then verify that they are in fact correct. So I'm going to start up a proxy to run over the VSOC so that Amazon or Vault can run without any changes. And then I'm going to do the second step in the process. I'm going to run an enclave. And what I'm going to do is I'm going to slice off some memory and some CPUs, and I'm going to provide the image file that we had. And that's up and running now. I can ask Amazon what they know, and Amazon has an ID for it, and it's got the same measurements that we had before, enabling us to verify that the image has not been tampered with. To the outside world, Vault looks just like normal. There's absolutely no changes. I connect to Vault the same way. I can put secrets into Vault. I can take secrets out of Vault. The real magic, however, is since Vault isn't running on this machine, actually, Vault is running inside of a Nitro enclave. There's no way to get to it. The attack surface has been removed. So in a very simple way, what Anjuna is going to do is not require you to hire engineers to go into the low level and figure out how to do a proxy for the HTTP traffic or rewrite your application. We're literally going to boil it down to those two steps. Take any application, and I'm going to build the application, and I'm going to run the application. And this works with Kubernetes. This works with bare EC2 instances. This works with other clouds, whether it's GCP, whether it's Azure, and this works on-prem.
Oh, pretty cool. Yeah, that's pretty cool. And yeah, that definitely does make it a lot easier. And thanks even for that demo. Yeah, that was a really cool demo and great that it all worked out. Uh, yeah, without hiccups. But really cool that Anjuna can do this sort of protection for even HashiCorp Vault. And who would have thought, that HashiCorp Vault, could get hacked so easily. But that was
Well,
really.
it's not easy, and this was the open source version of HashiCorp Vault. The production version does a different one, but it's all applications have this challenge, right? If I've encrypted my database, when I pull that data into memory, it's free, it's available. Anybody can get access to it.
Mhm, mhm. All right, all right. And you know, yeah, so that's really cool that you spoke about. What are some of the other features apart from, the core features that you just showed us? What are some of the other features that Anjuna Sea Glass has that could help with security?
I think the most important one is due to the point of privilege that we have, right? All enclaves restrict data into and out of the enclave. And we write the code, we write the shim layer that enables that so that you don't have to modify the application to follow those rules. We have the ability to um, modify the data as it's going into and out of the enclave. So through policy, we can automatically encrypt data that's going to disk, or we can bind to a TLS certificate at that point in time. So if you wanted to set up a private network, a private mesh of sorts, where you distributed a certificate out to each of the nodes that could prove its identity, you can set up a private network where you can do mutually attested TLS basically out of the box and specify that from policy. So it's really the policies that you apply on top of it for what other restrictions do you want to put onto the environment, and then who do you want to talk to? How do you identify the code that you're participating with? Those are the things that enable us to then connect in and do additional things.
Mhm. And in terms of setup, the let's say you start using Anjuna, how long does it take? What's the process to just get set up, and how do you configure these applications for confidential computing? What's the setup like?
Our record at the moment is 15 minutes. We
Oh,
were doing a demo with a customer, and one of our sales engineers said, "What application?" And he basically set it up for him on the fly in the course of the demo itself. So it's really going to be paced on the customer's environment. So when I'm working with a large bank, it may take them months just to provision an EC2 instance, and we're going to be along for the ride on that. But the actual process of adding Injuna, we don't have a SaaS application. Most of our customers, as you can guess, are highly paranoid, and they don't want to call a startup and say, "Hey, can we run our code today?" That's not going to happen. So we sell our software, and our customers will then download our software. And it's literally that set of command line tools that enable you to build and run. And so once you deploy those into the environment that you need to operate in, whether you're using Circle CI or Jenkins for your build environments, or whether you're using Terraform on the back end to set up your environments, you're ready to go.
all right, all right. Neat. And which are the roles within the organization that you see using Anjuna and even benefiting from Anjuna the most? There may be different roles ranging from like the startups to the large enterprises, but which are some of the most common roles that you see?
I, Obviously, the DevOps role is one that we impact because we provide a way to take an existing application and essentially take advantage of confidential computing without modifying that application. As an organization gets larger, it comes back to the use cases. So in a very large organization, for example, there'll be a PKI team, and that PKI team may be interested in protecting key distribution and key material management through us. A lot of times we'll start in the CISO's office or the CIO's office where they're trying to solve a problem where they can't get permission to run an application where they want to run it. And then we can provide the tools to make that happen.
All right, very cool. As we wind down, Steve, I want to ask, looking ahead a year or two from now, what do you see on the horizon for Anjuna, for even the space of confidential computing? What excites you the most?
Part of the reason I took the job is confidential computing is a fundamental shift in computer architecture and changes the way you think about how you can draw a perimeter around what it is I want to protect, because I no longer have to protect a machine by putting it in a cage. I can protect workloads on a machine and think about that isolation in a different way. So one of the things that excites me personally, and one of the reasons I took the job, is how often you get an opportunity in your career to fundamentally change computer architecture. What I think is going to be more exciting is when people are able to run their jobs securely and you can draw a much tinier circle of trust, and really take advantage of not just the three primary hyperscalers, but even a number of additional other resources like the DeFi folks, and take advantage of distributed computing in a way that's much safer than it is today.
Oh, yeah, yeah, sounds exciting. And like you started out saying, you see that, it's not going to be called confidential computing for too long. It's just going to be computing, and it's going to become just the natural way of how organizations run applications. And yeah, that would be really cool.
That's
So
right.
thanks so much, Steve, for joining us and just sharing all of your views and even giving us, just a great overview of Anjuna with uh, really cool demo as well. Really enjoyed chatting with you. Thanks so much for joining us.
My
Um,
pleasure. It absolutely enjoyed talking about Anjuna and having a chance to talk to your audience.
right. And before you go, just one question to get to know you a little bit more. What would be your alternate career path if not for your job in tech?
That's a really tough question for me because I have more hobbies than I care to number. Um, at one point considered going to the Coast Guard as an alternative hobby. I love being out on the water.
Oh, all right. Wow. Okay. Do you have a boat or something of that sort?
I do. I do have a, small sailboat that my wife and I get out on San Francisco Bay on fairly frequently. So it's a fun hobby.
That's cool. That's cool. Yeah. So you're living it out. Um, with that, we come to the end of this conversation. And thank you so much, our listeners and viewers, for tuning in. We hope you enjoyed this conversation about confidential computing and Anjuna. If you're interested in what they're up to, definitely go and check out Anjuna's website and see what confidential computing is all about and how it can help you be more secure in the cloud. Thank you so much for joining us, and we'll see you on the next one. Bye-bye.